Have you ever wondered how light travels from a source to our eyes? Let's take a moment to delve into this fascinating journey. Imagine light waves, like those emitted from the sun, sailing through space. They're on a mission, and that mission involves interacting with various materials they encounter along their path. Light has an interesting relationship with different materials. It can easily travel through transparent materials like a clear glass window. Translucent materials like frosted glass allow light to partially travel through. But when light meets an opaque material like a brick wall, it's a different story. Light waves reflect off these surfaces and bounce into our eyes, enabling us to see the world around us. So, although light's journey seems straightforward, there's a lot happening behind the scenes. So light's journey from its source to our eyes is not as simple as it might seem. Now, how can we visualize this journey of light? Well, one of the most effective ways is through the concept of the light ray. Think of a light ray as a symbolic representation of light's path, a way to trace the journey that light waves undertake. It's like drawing a map of light's voyage, and the tool we use for this is something called a ray diagram. Ray diagrams are simple yet powerful tools for interpreting and depicting the travel of light. A ray diagram involves drawing straight lines with arrows, each line representing a single ray of light, and the arrow showing the direction in which the ray is moving. It's a way to apply our understanding of how light behaves, and interestingly, it also helps us identify any misconceptions we may have about light's travel. Ray diagrams, thus, are a powerful tool to decode the journey of light. Did you know that as light moves away from its source, it spreads out? That's right, whether it's a flashlight or the glow from your computer screen, light tends to cover a wider area the further it gets from its origin. This is because as a beam of light moves outwards, it disperses to illuminate more space. But wait, there's an exception. Enter the laser beam. Unlike your typical sources of light, laser beams are unique. They have this remarkable ability to stay focused over great distances. Picture this. A standard laser beam would only spread out by about 1 meter over a distance of 1 kilometer. That's the length of about 10 football fields. So while most light sources spread and disperse, laser beams keep their narrow pathway, staying true to their course. That's why they're used in everything from cutting-edge medical procedures to your everyday barcode scanner. So, not all light behaves the same way when it travels. But regardless of how much it spreads, one thing remains constant. Light always travels in straight lines. Now, let's think about a beam of light. It's not just one entity, but rather a collection of many individual rays. Each of these rays can be represented as a straight line with an arrow. This arrow is more than just a decoration. It has a purpose. It shows the direction in which the light ray is traveling. Let's imagine a scenario. You're in a dark room and you switch on a flashlight. The beam of light you see isn't a single entity, but a collection of individual rays. Each ray is traveling in a straight line away from the source, which in this case is your flashlight. The arrows, if we could see them, would all be pointing in the same direction, showing us the path that each ray is taking. Now, what happens when these rays encounter different materials? Let's say you shine your flashlight onto a mirror, a clear glass window, or a solid wall. Despite these interactions, the path of each light ray remains straight. Sure, it might reflect off the mirror, pass through the glass, or stop at the wall, but at no point does it deviate from its straight path. This characteristic of light traveling in straight lines is fundamental to how we perceive the world. It's why shadows form, why we can see reflections in mirrors, and why we perceive objects as having a definite shape and location. Essentially, it's a crucial part of what makes sight possible. So let's take a moment to appreciate the humble light ray. It may seem simple, but it carries a profound truth. Despite all the complexities of our universe, all the different materials and mediums it may encounter on its journey, a ray of light remains steadfast and true to its course. No matter what, light's journey is always a straight path, showing us the way, bright and clear.